Hi everybody, the purpose of this video is to go over some of the problems in homework 1.7. So here we are, and here is the very first problem. And this is where we have basically 6 inequalities in algebraic form, and then 1, 2, 3, 4 inequalities in graph form, and we need to write down, we need to mix and match so that they have the appropriate inequality in interval notation. So here we go. This is all values of x which is strictly less than 7. So that means we're going to have a parenthesis by -7, and it's going to go all the way down to infinity. And that would be this symbol right here, parenthesis -7, all the way down to -infinity. Now, this is all numbers less than or equal to 7. So that will go from -infinity to 7, including 7, which is what this one is right here. No, that's -7. That would be the wrong one. We want to use this one, -infinity to 7, including 7. Let's try that again. Always helps if you click one mouse button at a time. Now here we have the interval from -1, not including -1, so parenthesis, to +7, including +7, so that would be your bracket. And that would be this one right here, parenthesis by -1, bracket by +7. Now this one actually happens to be the entire real line. If you take a negative number and square it, you get a positive number. You take 0 and square it, you get 0. And of course, if you take a positive number and square it, you get, you guessed it, a positive number. Now number 5 is all values of x that are greater than -7. So that's going to be greater than or equal to -7. So that is going to be -7 and including -7 all the way up to infinity. And there it is. And then for 6, this is all values of x greater than or equal to +7. So we're going to include +7 bracket all the way to infinity. There we go. And down here, all we need to do is map the bracket and the parenthesis to the appropriate interval. So here we have a bracket by -1. There it is, a parenthesis by 7. That's the one that we want. This one is a bracket from 0 and we have a bracket by 0 and a bracket by 3. That's this one right here. Now this one is the union of 2 intervals, and there's only one here that has a union of 2 intervals. Yep, it's this one right here. So this one we go there. But basically this is all intervals. This is the interval from -infinity all the way up to -1, not including -1, union with the interval from 7, not including 7, all the way to infinity. And wait, that belongs here. I put that in 8 by mistake. You can't have 2 and 8. There we go. And then finally, we have the interval from -infinity to -7, including -7. That goes here. And let's see if I'm right. I don't want to see if I'm right. Finally, I finally got this one right. Yes, I've tried this a couple of times, and it screwed up. Now, this one is explain how to determine whether to use a parenthesis or a square bracket when writing the solution set of a linear equation in a linear inequality in interval notation. And the first one says a square bracket is used to show that a number is part of the solution set. And a parenthesis is used to indicate that the number is not part of the solution set. So that's A. B says a parenthesis is used to show that a number is part of the solution set. Well, that is dead wrong. And the square bracket is used to indicate that the number is not part, and that is also wrong. It is part A because we use a square bracket to show that it is included and a parenthesis to show that the number on the end is not. So we would want to choose A. All right, so what's our next question? Okay, now we need to solve inequalities. Now this inequality is relatively straightforward. And here we have -7x plus 5 is equal to 26. -7x plus 5, I'm sorry, is less than or equal to 26. All right, cool. So we want to treat this pretty much the same way we treat an equation. We want to isolate the x, and we'll do that by subtracting 5 from both sides. Well, that's kind of convenient because that gives us that negative 7x is less than or equal to 26 minus 21. 26 minus 5 is positive 21. Then I want to divide both sides by negative 7. And when I do, these cancel. I have x, but since I divided by a negative number, the direction of the inequality symbol will switch. So it does. And now I have 20 divided by 21 divided by negative 7, which is negative 3. So now we have x is strictly greater than or equal to negative 3. And in interval notation, that will be bracket negative 3, comma, infinity. There we go. And how do we put that in here? Well, pretty much the way I just described it. It is going to be bracket negative 3 is comma infinity, and actually what you can do is do a backslash INF, and there's your infinity, parenthesis. And lo and behold, I'm 2 for 2. Actually, wait, that's 3 for 3. So here we have 1/5 x plus 1/2 x minus 1/3 x plus 2 is less than or equal to 1/10. Now what we can do is get rid of the fractions, and to do that we would actually need to find a least common multiple of 5, 2, 3, and 10. So we want to find the LCM of these. LCM, least common multiple. And actually that would be 30. That's the smallest number that has all of these as a factor. So we want to multiply this entire equation by 30. It's kind of like using the distributive property on steroids. So we'll have 30 times 1/5 x, which would be 6x, plus 30 times 1/2 x, which would be 15x, minus 30 times 1/3, which would be minus 10 times the quantity x plus 2. It's going to be less than or equal to 30 divided by 10, which is 3. So there we go. No more fractions. We need to deal, well, we can first simplify these, or combine these since they're like terms. This is just going to be 21x. We need to deal with this grouping symbol here, and we use the distributive property, so that'll be minus 10 times x, which is minus 10x, plus negative 10 times 2, which will be minus 20. And that'll be less than or equal to 3. We can simplify some more. We can combine these like terms, and that will give me 11x minus 20 is less than or equal to 3. I can add 3 to both sides. No, correction, I can add 20 to both sides. And that will give me that 11x, these cancel, is less than or equal to 23. I can divide both sides by x. And that will give, no, I don't want to do that. I want to divide both sides by 11. But dividing by x would be a little absurd. These will cancel, and I'll have x is less than or equal to 23 over 11. That's pretty much all we can do with that. Now what would that look like? That should look like negative infinity, comma, 23 over 11, bracket. And let's see if that's right. So parenthesis, negative infinity, comma, 23 slash for fraction 11 over here. Go move the cursor, bracket, and let's see if I'm right. Yes, I actually did it right. I was a little worried about that one. Okay, so this one is just like the last couple of problems we did, so I'm going to skip it, as is that. This one we have correct. The cost to produce a wire is is going to be 30 times x plus 500, while the revenue is 40x. Find the interval where the product will at least break even. Well, if you remember from class, this is basically solving the problem of figuring out when R is greater than or equal to C. Here we have R is equal to 40x. C is equal to 30x plus 500. So we basically want to substitute and go to town. So R is 40x. We replace 40x with R. C is 30x plus 500. We do the substitution there. 30x plus 500. And then we go ahead and we solve for x. And of course I want to do this in such a way that I have positive coefficients, so I don't have to worry about dividing by negative numbers and flipping signs. So I'm going to subtract 30 from both sides, 30x from both sides. These will cancel. I will have 10x is greater than or equal to 500. Divide both sides by 10. And I have x is greater than equal to 50 units. Now it says here that the interval where the product will at least break even, where the revenue will be at least the cost or higher, is going to be this. So they're actually looking for an interval. Now the interval is going to be from 50 and anything higher than 50, so 50 to infinity. Notice we will include 50, so it's going to be a bracket. We're going to have a parenthesis by infinity. And that will be bracket 50, comma, backslash INF for infinity, parenthesis. And there we go. Okay, now this is the problem that I talked about in class, which you might run into. Here, it's the exact same problem. We want to figure out when R is going to be greater than or equal to C. Of course, now R is 45x. C is going to be 105. The cost to produce is 105x plus 360. Okay, there's no way that you're ever going to make money in this model because it costs per unit. It costs $65 or 65. That's okay. Let's just assume that's dollars. $65 more to produce the unit than you get for it. But let's just go ahead and do the math. Here we're going to do the substitutions. We have 45x is equal to 105x plus 360. No, I'm sorry, it's going to be greater than or equal to. And we can subtract, well, I want to keep positive coefficients, so I'm going to subtract both sides by 45x. And then I will have, these will cancel, I'll have 0 is greater than or equal to 60x plus 360. Now remember, we are producing units, so the only values that x can take are basically the natural numbers. So x can only take on the values of 1, 2, 3, all the way up, because once again, we're producing units. We cannot produce negative units. So we're getting here, and knowing that x can only be positive integers, or the natural numbers, there's no way that this can be true. This is actually a contradiction. This is false. This says you can never ever make money, which is our answer, which is B. Okay, so these are the same types of problems. I'm just going to move on through them. Okay, here is one where we have the compound inequality. Although this is pretty straightforward, let me just go ahead and do this one anyways. We have negative 7 is strictly less than 3 plus 2x, which is strictly less than 9. Okay, once again, we just basically want to isolate x. However, in this case, we want to isolate x in the middle. We can do that by subtracting 3 from all three sides. So negative 3, negative 3, negative 3. That cancels. We have negative 10 is strictly less than 2x. is strictly less than 6. And then we can divide all three sides by 2. We have negative 5 is strictly less than x is strictly less than 3. And that gives us the open interval. Remember, we have parenthesis because of the strict inequality, negative 5, comma 3 with a parenthesis because of the strict inequality. And that should be what we get here. Well, according to this thing, although I put the exact same answer in that they did, unless I used a comma instead of a period, which I don't think I did. Like I mentioned before, I got the exact same answer they did, and apparently it was wrong. So if you've seen this, please either let me know, or I'll make it a point to go through everybody's homework to make sure that you guys aren't being penalized for doing something that you did correctly anyways. Okay, so moving on. Okay, well, this is an interesting problem, so let's just go ahead and take a look at this one. See, I'm at 14, so I'm actually getting pretty close. Okay, so we have negative 1 is less than or equal to 2m plus 8 divided by 2 is less than or equal to 12. Okay, well, the first thing you might want to do is get rid of the fraction, so let's multiply the entire equation by 2. If we do, we will have negative 2 is less than or equal to 2m plus 8, which is less than or equal to 24. We can subtract 8 from both sides, minus 8 here, all three sides, I apologize. And if we do, these cancel, I will have negative 10. It's going to be less than or equal to 2 times m. 24 minus 8 is going to be 16, so it's going to be less than or equal to 16. I can divide all three sides by 2. Negative 10 divided by 2 is negative 5. That's going to be less than or equal to, these cancel, we have m, and that's going to be less than or equal to 8. And let's see if I have better luck with this one. Negative 5, comma 8. There we go. Okay, so at least that one they took. And here is one where we need to solve a quadratic inequality. So let's go ahead and deal with this one. And remember, the first thing that we want to do, we have a quadratic inequality, is we want to solve the corresponding quadratic equation. And the corresponding quadratic equation is going to be x squared minus 2x minus 15 is equal to 0. Okay, now it turns out that this one is factorable because we want to have factors of 15 that when you subtract them give you minus 2, and that would be 3 and minus 5. So we have x plus 3 and we have x minus 5. We will if we have x plus 3 times x minus 5, this can expand to become this polynomial. You'll have x squared minus 5x plus 3x negative 2 minus 15. And if that's the case, our solutions are going to be x is equal to negative 3, x is equal to positive 5. Okay, so here's our number line. Here's negative 3. Here is 5. We have 3 intervals. Here's 1, 2, and 3. Okay, so let's go ahead and let's take a look at interval 2. For interval 2, and then remember, we want to see which one of these inequalities which one of these intervals satisfies the inequality, makes the inequality true. So, and their inequality is x squared minus 2x minus 15 is strictly greater than 0. Okay, so for interval number 2, since 0 is somewhere in here, we can let x be equal to 0. If that's the case, we have negative 15 is greater than 0, which is false. So this interval does not satisfy the inequality. Chances are this one does, and so does this one, but let's just make sure. For interval 1, we can let x be equal to 4. X will be equal to negative 4. And then negative 4 squared will be 16. Minus 2 times negative 4, that's just plus 8. Minus 15. Well, that is going to be 16 minus 15 is 1. That's going to be equal to 9, which is true. That's greater than 0. So this is true. So this does indeed work. And then for interval 3, how about we do x equals 10? 10 is a really easy number to work with. 10 squared is 100. Minus 20, 2 times 10. Minus 15. Well, that's basically 10 minus 35. That should be 65, which of course is indeed greater than 0, so this is true. So our interval should be the union of this one right here and this one right here. And that is going to be from negative infinity to negative 3. Since we have a strict inequality, it's going to be a parenthesis, union, and then from 5, and again we have a strict inequality, so we're going to have a parenthesis, all the way up to infinity. And that should be our answer. So what do we put in here? We put in parenthesis. Must just be wrong. Well, much of them say it's wrong. Negative, then our infinity. We can use /i and f to get that, comma, negative 3, close parenthesis. Now for the union symbol, you can do \cup, cup, and there it is. And then parenthesis, wrong parenthesis, the other parenthesis, 5, comma, /INF. All right, let's see if that works. There we go. Okay, so that's how those things work. Let's see if we have another. Okay, so let's take a look at this problem. Here we have the inequality. Oh, let's use this thing. 5x squared plus 12x is less than or equal to 9. Now step number 1 is to solve the corresponding quadratic equation. Now the corresponding quadratic equation is going to be 5x squared plus 12x is equal to 9, or 5x squared plus 12x minus 9 is equal to 0. And this does indeed factor. One of the things which is kind of convenient is that this 5 is a prime number, so we're going to have 5x over here, and then x over here. And now, if we actually add a 3 here and subtract a 3 here, this should indeed work. 5x times x is 5x squared. 5x times 3 is plus 15x. Negative 3 times x is negative 3x. And then we have our negative 9. And then the middle term is found by combining these two, which will give us our 12x. So this works out. And this also tells us that our solution, and this is equal to 0, and now this also tells us that our solutions are x is equal to positive 3/5, and x is equal to negative 3. So for step number 2, you want to draw out the number line and find our intervals, more or less. Here is negative 3. Here is 3/5, which is actually also 0.6. And now we need to test our intervals. And of course, we're going to have intervals 1, 2, and 3. Okay, so for interval 1, how about if we let x be equal to negative 10? I like negative 10 because negative 10 is pretty easy to compute. All right, well, negative 10 squared is positive 100 times 5 is 500. And that's going to be plus 12 times negative 10, which is negative 120. Of course, that's going to be equal to 380, which is that less than 9? No, it is not. This is false. So this cannot be a solution. This interval is not a solution. How about interval 2? Well, in this particular case, that's the interval between -3 and 3/5, and you'll never guess which number is contained in that interval. Yep, x is equal to 0. All right, so we substitute 0 for x. We're going to have 5 times 0 squared, which is 0, plus 12 times 0, which is 0. This equals 0. And is this less than or equal to 9? Why, yes, it is. So this interval satisfies the inequality. And as you might guess, interval 3 does not. Here we can use x is equal to 10 because, once again, it's easy to compute. All right, well, 10 squared is 100 times 5 is 500. 10 times 12 is 120. That's going to be equal to 620. And that is that less than or equal to 9? No, it is not. This is false. So this right here is the interval. This right here is the interval that satisfies the inequality. Now notice it is a non-strict inequality, so we want to include the -3 and we want to include the positive 3/5. So our solution in interval notation will be bracket -3, comma 3/5, bracket. And I really hope this works. Bracket -3, comma 3/5, just space it over, bracket, and it was right. Okay. Okay, let's take a look at this inequality. This one should be a fun one. Here we have 6 over x minus 5 is less than or equal to 5 over x minus 4. All right, so the very first thing we want to do is, remember, we want to have a single fraction on one side and then 0 on the other side. So we're going to subtract both sides by 5 over x minus 4, and if we do, we are going to have 6 over x minus 5 minus 5 over x minus 4. Let me get rid of that little thing there. And now we need to make this one fraction, and we can do that by forming a common denominator. Here I can multiply this fraction by x minus 4 over x minus 4. And then this one by x minus 5 over x minus 5. And of course this will be less than or equal to 0. Okay, so basically in the numerator I'm going to have 6 times x, which is 6x. 6 times -4, which will be minus 24. Minus 5 times x is minus 5x. And then minus 5 times -5 is plus 25. That's all going to be over the product of x minus 4 over x minus 5. Now I could go ahead and expand that, but I would actually have to go back and then just factor it back out again, so to figure out what these to find the solutions. So might as well just leave it just like that. And of course this is less than or equal to 0. I can do some simplifications. 6x minus 5x, well, that's just x. -24 plus 25 is plus 1, and that is going to be over x minus 4 times x minus 5. So here is our fraction on one side and 0 on the other. Now now we can determine where the numerator equals 0 and where the denominator is equal to 0. Because when the denominator is equal to 0, this expression is undefined, and when the numerator equals to 0, this thing satisfies the corresponding equality, and they will define our intervals. And that occurs when x is equal to -1, and then the denominator equals 0 when x is equal to 4, and x is equal to 5. As a consequence, these two cannot be part of the solution. These will always have to be excluded. Since we're dealing with a non-strict inequality, this value will always be included. Now we can define our intervals. So here is my number line. Here's -1. Here is 4. And here is 5. So we have 1, 2, 3, 4 intervals to test. So let's go ahead and test interval 1. And we're going to test it against the original inequality, which is 6 over x minus 5 is less than or equal to 5 over x minus 4. And let's use x is equal to -5. If we do, we will have, no, I'm sorry. Yeah, x is equal to -5. If we do, we will have 6 over -5 minus 5 is less than or equal to 5 over -5 minus 4. And that will be equal to -6/10, or that will become -6/10 is less than or equal to -5/9. Now, it's probably not clear if this inequality is true or not, so we can actually use the calculator to get some values. This, of course, is going to be -0.6. This is going to be less than or equal to -0.55. And indeed, -6 is less than -0.55, so this is true. Which means that this value, that this interval, including -1, will be part of the solution. Okay, so that's interval 1. Let's check on interval 2. Now notice that interval 2 goes through 0. So hey, let's use 0. If we do, we will have 6 divided by 0 minus 5, -5, is less than or equal to 5 divided by 0 minus 4, -4. This might be clear in decimal form. Well, 6 over -5 is nothing more than -1.2. And 5 over -4 is nothing more than -1.25. Okay, this value is less than that value, so this happens to be false. So we will not include this interval. Now the fun one is going to be the interval between -4 and +4 and 5. And the only reasonable choice that we would have here is to let x be equal to 4.5. Now remember, here we let x be equal to 0. Okay, if we did that, we will have 6 over 4.5 minus 5 is less than or equal to 5 over 4.5 minus 4. That will become 6 over -0.5 is less than or equal to 5 over +0.5. And that becomes 6 divided by 0.5 is -12, less than or equal to 5 divided by 0.5, which is +10. This is true. So this interval is part of the solution, but not 4 and not 5, because they make the inequality undefined. And then finally, for interval number 4, how about we just let x be equal to 10? 10 is a nice easy number to work with. Then you are going to have 6 divided by 10 minus 5. That's going to be 6 over 5. And then we're going to have 5 divided by 10 minus 4. That's going to be 5 over 6. Oops. Less than or equal to. And again, it might be better to to use a calculator for this. And if you did, you would have 1.2 is less than or equal to 0.8333, which does not satisfy the inequality. This is false. So then this interval will not be included. So that means that the interval that solves this inequality is going to be the interval from negative infinity to negative 1, with including negative 1. So that is going to be negative infinity, comma, 1, bracket, union with the open interval between 4 and 5, because we cannot use 4 and 5 because they make the denominator go to 0. And let's see if that is right. Bracket, and then for the union I can do backslash cup, C-U-P, and then we're going to have parenthesis 4 comma 5. And there we go. That's how that one works. And basically all the other rationals work pretty much the same way. And that's all I have for this. I hope this helps you with your homework. If it doesn't, I would encourage you to go through the examples or the Help Me Solve This stuff. They should help you as well. And I hope those of you that have not yet turned in your homework will be able to use this stuff and have your homework in by Thursday. And with that, this is Bob Boyle signing off.